All right, we're going to continue on with adding and editing attributes. So first, when you go to add an attribute, which we're going to do here with this function, you'll see there's 4 different parameters you can specify. The first is a name. That's the name that's going to appear at the top of the column for the attribute. Area, name, count, DBH, soil type is all kinds of different ones. Remember that if you're going to load it into ArcGIS, you're going to have to keep your attribute names to 10 characters or less with no punctuation except underscores, or it simply won't load them. Next is the area type, int for integers or numeric values that don't have a decimal, float for floating point or those that might. And this is really important because you usually won't use integer. You might use it for a count, but that's about all I ever use it for. Otherwise I use float because if we're going to be doing any kind of arithmetic, we almost always want to have that decimal point so we keep high accuracy. SDR for strings or any kind of text like our hello world example or names or other label information. Then you're going to have an attribute width, which normally you don't need to specify because if you leave it out, you'll get the default of 4 bytes for an integer, 16.6 characters for a float, and 200, or I think that's tens places, and 254 for strings. Okay, and then there's a default value. Now I do tend to specify this because I like it to have something in it other than an empty value. And down here you'll see how to add them, where first we're going to go ahead and add a name as a string up to 254 characters and initialize it to test. You could initialize it to something else. Here we're going to add area, which we want to be float, so we can do calculations and keep our accuracy, and I'm going to initialize it to a -1. I like to do that so I know the area hasn't been calculated yet, so that it's not accurate, because of course -1 area is impossible. Now notice we also left out the length, which you can do, but if we leave out a parameter in Python, then we need to specify the name of the parameter with name equals and then the value we want to use for that parameter. Same thing here with count being an integer and setting it equal to a -1 so we know it's not initialized. So I'm going to take this code and paste it into Python, and then I'm going to go ahead and grab one of our files. I'll just use the box because that'll be easy, and put its path in here, and this is going to load that up and add those attribute types to it. It's very fast, not very exciting until we can go ahead and set an attribute value. So here we're going to set the name to row 1, and that's the attribute name, row 0, and we're going to call it row 1. Okay, and then we're going to go ahead and get that value back and print it out. Let's go ahead and run it, and boom, there it is. Okay, and then we can save that one back out again, load it into Arc, and make sure those are working. Okay, moving right along, we're going to put together a bunch of the stuff we've learned into how to put points inside of an area. And this is something we do fairly commonly when we're doing research. We want to have random points within a polygonal area. The first chunk of code here, and let's see, oh yeah, I'm just going to go ahead and keep working in this file. So the first chunk of code is going to go ahead and load our Humboldt County zoning file and print out the number of features, and then it's going to go and just pull out the 2000th one. In other words, if the index isn't equal to 2000, it's going to go ahead and delete the feature at that index. So when it does that, it's going to then save out a sample area. And then I've got QGIS here, and I'm going to go ahead and check and see, yep, there's an area. You could do a different one, or you could do a random one. If you load a shapefile into a GIS application while you're programming, make sure you remove it so it can overwrite it. And then we're going to go back here. Now, what we want to do is we want to find the bounds of our shape, because we want to only put random values into the rectangular area of our shape. So first thing to do is get the bounds. Now this is going to return an array of values, and then we can index into that array. The array entries start at 0 and then go 1, 2, 3. Okay, so 0 is going to be the x minimum, 1 is going to be the y minimum, 2 is going to be the x max, and then 3 is going to be the y max. So the other way to look at this is the minimum, or the most western coordinate in the polygon. X max is going to be the most eastern coordinate, and then y min is going to be in the south, y max is going to be in the north. If we go ahead and run that, we're going to see here I've formatted it and printed it out, and you can see that our x min is smaller than our x max, and these are about 400,000, which is Humboldt County. And then we've got our y min and our y max, and it's around 4 million, which is, again, we're in the right area. Now we use x and y a lot because if we're using projected data, we're going to be doing eastings and northings. If we're using geographic data, we're going to be using longitudes and latitudes. X and y is the most general, so you'll see that quite a bit. To make sure that all of our shapefiles are in the same coordinate reference system, we need to get the CRS from our existing file. So I'm just going to paste that code in and run it. And this function will return the CRS, or coordinate reference system, and then you'll see I'm just going to format and print it out. Now it comes back in this interesting format where it's inside what's called a dictionary and then inside of a string, and we're not going to deal with that. We're just going to go, okay, it's 26910, and we can just use that because that's all we really need is the UPSG code. Okay, and there's some more information on the website about that, but let's get into the fun part. Let's create some random points. All right, so take a look at this code. You can see what we're doing is we've done before, created a new vector data set, set the type to points. There's our CRS, or coordinate reference system. Got to set that. And then we're going to do a loop where we set num equal to 0 and loop until num is equal to or over 100. So while it's less than 100. And here we're just going to add 1 each time. And each time through this loop, we're going to call a function called Randint. That's going to generate a random number between our x min and our x max. So between our most westerly to easterly value. Same thing for y, the most southerly to northerly, so we're going to get random values between these two in a box, and then we're going to create a geometry. Now, one problem is our geometry that we're going to be putting this into may not be a box, right? It could be any shape. So we not only have to generate x and y values inside the bounding box for our geometry, we also have to make sure that it's contained inside our geometry. So we can use sample dataset.contains with our new point geometry and see if our point is contained inside our polygon. Then if that's true, we're going to go ahead and add a feature as that geometry, or add that geometry as a feature. And then go ahead and add 1 so that we don't stay in our loop forever. And last but not least, we'll go ahead and save this to an output folder. If we go ahead and run this, see it runs pretty quick. And then I just happen to have QGIS up where I can drag and drop. There's our polygon. And then we can drop our points into QGIS, and we can see, hey, we've got a bunch of random points inside any polygons. Now we've got a method, we can drop random points in any polygon. And this is really unlimited what you can do now because you can create your own shapes. You can do random work. Of course, we could also do a whole bunch of other analysis to create different types of spatial data. We can relate them. We can do all kinds of different vector operations on them.